Dear students, so we have seen the different parameters of rotation, that is angular velocity, angular displacement, angular acceleration, and also we have seen the different laws of motion parameters, that is velocity, displacement and acceleration. Now we want to establish relationship between linear motion, linear motion and angular motion, or say rotation. So now we are going to try establishing a relationship between this. When we say angular, that is not the proper term to be used, but I use this because we talk about linear velocity, linear displacement, linear acceleration, angular velocity, angular displacement and angular acceleration. But this term should be actually circular motion, or you can say curvilinear motion. Okay, so the difference between these different motions, curvilinear, translational, rotational, then projectile, these things we have already seen. So now we are going to talk about this. Okay, so we will start by considering a circle. Okay, what I have is a circle, and let the radius of the circle be r. Okay, and I'm considering 2 points, point A and point B. Okay, there are 2 points, point A and point B, and I'm going to consider this particular angle as d theta, the angle between this center, which is OA and OB, that is angle AOB. Angle AOB is d theta, and the radius equal to r. Now what I'm going to do is I'm going to consider an object, a point here, in a matter of say time t. Okay, in a matter of time t, this object is rotating and this point got shifted to this particular location. So earlier this point was A, after time t it got shifted to point B. So I want to know how much is this distance. I'm calling it as ds. So if we have the equation angle equal to r by radius, there's a relation that you learned from school itself, I guess. So here the angle is d theta, arc is ds, and the radius is r. Okay, and if you're observing, what is this ds? ds is change in linear displacement, right? This is the linear displacement, and d theta is the angular displacement. So from here you can, or we get the very first relationship, that is linear displacement is equal to r times angular displacement, or we can write s equal to r theta. That's the first relation that we are getting. Okay, the relation between linear displacement and angular displacement. Now in the same, I'm going to try to get the relationship between the velocity. Okay, so what is the linear velocity? Linear velocity normally represented as v. Okay, v, what will be v? Change in displacement, that is displacement by time, right? So the displacement is ds divided by dt, or say in our case it is not dt, it is t. Okay, ds by t, because this happened in time t. The time what we are considering is t. Okay, so ds by t is the velocity. Now what is ds? ds is, we have already got the value of ds. ds is r d theta, so I can represent this as r d theta by t. Okay, now if I look at this particular parameters, what is it? It is angular displacement divided by time, that is rate of change of angular displacement. What will be the rate of change of angular displacement? It is basically our omega. So I am getting the second expression from here. V is equal to r omega. That's my second expression. The relationship between displacement I got, the relationship between velocity I got. Linear velocity equal to r times angular velocity. Now we need to think about the acceleration. Okay, what is the acceleration? dv by dt, or the change in velocity divided by time. The rate of change of velocity is called as our linear acceleration. Okay, so now we have the expression for v as r omega. So if I write it here, r omega by dt. Okay, here r is the radius, which is a constant, so I can take it out. So this will give me r times d by dt of omega. And what is rate of change of angular velocity called? Rate of change of angular velocity is my angular acceleration alpha. That is, I'm getting the third equation. A is equal to r times alpha. Okay, these are the three relations which we are going to use when we are connecting linear motion with circular motion. Okay, so there are going to be problems for the examination connecting these different things. So let's try one simple problem, okay, to understand the concept. Now I'm not so sure whether you are able to see the things clearly. I will read it for you, and I will share this final pages as a PDF so that it will be easy for you to read. So I will read it for you. A passenger car is traveling at 65 km/h on a level road. Okay, so you have a level road on which a car is traveling. Okay, a car is traveling at a speed of 65 km/h. Okay, so its velocity is given as v equal to 65 km/h. Then the distance from the road to the center of the wheel is 30 cm, which means that the wheel is having a radius, okay, radius of 30 cm. That is the radius of the wheel. And we are asked to calculate the magnitude of angular velocity omega and the constant angular acceleration if the car is brought to rest in 150 meters. So we are supposed to calculate the value of alpha, and the data given is it was brought to rest in 150 meter. That is, S is given as 150 meter. So this is the information that is available in the problem, and this text is not readable, so I kept it like this. So now we are going to see the situation. So what we have is the wheel which is rotating. When the wheel is rotating, this car is moving linearly. So this car is going to have linear acceleration, linear velocity and all, and this wheels will be having angular displacement, angular velocity and angular acceleration. So now we are trying to connect these two to provide or to fetch these information that we wanted. Okay, so we have the expression, three expression. Last page we have seen that S equal to r theta, V equal to r omega and A equal to r alpha. These are the three expressions we have in our hand. So now we are going to try calculating it. So the velocity of the vehicle is given in km/h. Okay, so a value in km/h is not suitable for us. We should convert it into meter per second. So first step what we are doing is we are converting the velocity into meter per second. So V is equal to 65 km/h, and what's the conversion? The conversion is 5 by 18. Okay, you might have done this when you are dealing with the physics in your school. Okay, 65 times 5 by 18, that is a value. So we are going to get the value of this as 18.06 meter per second. So that's the value of velocity in meter per second. Now what is asked in the first problem? We are asked to calculate the angular velocity. What is angular velocity? Omega. Omega is given by, we have the expression V equal to r omega, so omega equal to V by r. So omega equal to V by r. V is 18.06 and the radius is 30 centimeter. 30 centimeter means 0.3 meters. So on doing this, I'm going to get the value as 60.2 radian per second. Okay, that's the answer for the first part. A part, we want to calculate the angular velocity. And what about the B part? We are asked to calculate the angular acceleration if the car is brought to rest in 150 meter. So 150 meter is the linear displacement. Okay, so can we calculate the linear acceleration? Let's try that. So to calculate that, currently the car is running at a velocity of 18.06. Okay, so 18.06 means the u can be considered as 18.06 meter per second. What about the final velocity? It is 0. And they have given the distance, that is s is 150 meter, and you are asked to calculate the value of a, through which you can calculate alpha, because once we have the value of a, r alpha, the relation is available, alpha equal to a by r. So we'll calculate the a from the linear condition and we'll convert it into the circular condition. So what expression we can use here? V, u, a and s. So the expression is v square equal to u square plus 2as. So what will this give? 0 equal to 18.06 square plus 2a times 150. On solving this, I will be getting the value of a as minus 1.09 meter per second square. Why is it minus? Because it is retardation. Okay, it was traveling at this particular speed, it came to rest, which means he has applied brakes and it is retarding, hence the acceleration is negative. So once we have this, what will be alpha? Alpha is equal to a by r. The value of a is minus 1.09 and the value of r is 0.3, 30 centimeter, that is 0.3 meters, and we are going to get the value as 3.63 radian per second square. And that's the value of angular acceleration. And I forgot to put the minus, it is negative because it's deceleration. And here we have the angular velocity. So this is a simple problem where we related the linear and the circular motion together. So a car is the best example. The wheels are having rotational motion or circular motion, and the body of the frame of the vehicle or the body of the vehicle is having linear movement. So this is one such example. Let's try one more, because this is a very common problem that used to come for exam. That is the stepped pulley case. Okay, when you hear about stepped pulley, you should know what it is. So the diagram over here shows a stepped pulley. So there is one diameter for inside pulley and another diameter for the outside pulley, and this will be rotating together. Okay, either it will be rotating clockwise or it will be rotating anti-clockwise. So what is the basic difference of this pulley from the normal pulley? The difference is that the movement, the vertical movement, that is the upward or the downward movement of this block A and block B, this is block A, this is block B, depends upon the diameter. Okay, the diameter are different, so these two are going to move at different acceleration, different velocity or different displacement level. Okay, for the same rotation of the pulley. And here you need to have one more concept, the very basic concept from angular velocity. What is angular velocity? Angular velocity omega is the d theta by dt, that is change in displacement. Okay, change in displacement. So I want to know, if I'm considering a point here and if I'm considering a point here, what about the angular velocity? Will it be same or different? Say this point in a time t moved up to here. This point at the same time you're considering it will be moving up to this point, right? So basically you can see that the angle is same. Okay, the angle of rotation is same. When angle is same, time is same, omega is same. So whichever the point may be, whether there's a point here, 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 here or here, everywhere the angular velocity will be constant in this case. on a circular disk, angular velocity for every point will be same. But what about linear? If you are considering linear velocity, this is moving only this much in time t, but this is having a higher value, right? And why is that so? Those should be same, right? What is the relationship between velocity and linear velocity and angular velocity? We have the expression v is equal to r omega. So you can see here there is this r. So depending upon the r, the values will change. So for in this particular case, every point is having same omega. So the linear velocity will depends upon the radius. So as the radius increases, we will be having omega equal to v by r. Okay, omega is constant. So what is the relationship then? V is proportional to, if omega is a constant, V is proportional to r. Okay, which means that if the radius is more, the velocity will be more, because this point is traveling a lot of distance in the same time. At the same time, this point will be moving only a little distance compared to this point. Okay, that's what this says. So that is a concept that should be clear for you. It is the change in angle divided by time. Now we are moving to this particular problem. I know it is hard for you to see it, so I will read it for you. The step pulley shown in figure starts from rest. Okay, there's a rest condition, and accelerate at an acceleration, angular acceleration of alpha, it is equal to 2 radian per second square. So initially it is at rest and it is accelerating at 2 radian per second square. It can be clockwise, it can be anti-clockwise. It's not mentioned till now. How much time is required for block A to move 20 meter? Okay, we want this block A to move 20 meter. It is not said whether it is moving upward or it is moving downward. Nothing is said. So it can be anything. It can be moving upward or it can be moving downward. Whatever it is, we want the block A to move a linear displacement of 20 meter. Okay, 20 meter. So that is given, and we are asked to calculate the time required for this particular object, block A, to move 20 meter upward or downward. Find also the velocity of A and B at that instant. So at the instant when it has moved 20 meter, we want to calculate the velocity of A and velocity of B. So this is what needs to be done in this particular problem. So let's see how to solve this. Okay. So now I'm going to consider this A is moving by 20 meter. Okay, when this A moves by 20 meter, what will be the angular displacement? Okay, how much this pulley will be having change in angle. Okay, how much angle the angle change will be there. So when this moves by 20 meter, you can see that linearly, if this has to move 20 meter, this line, say if it is rotating clockwise, so this point moves down by 20 meter, which means it is going to have a linear displacement of 20 meter. Okay, it is going to rotate 20 meter. This outside circle is going to rotate 20 meters so that it can come down by 20 meter. So we have angle equal to arc by radius. Okay, that is the angle rotated. I'm calling it as theta. What is the arc length? It is 20 because it is moving by 20. Divided by radius. What is the radius of the outer circle? Because we are talking about A, the radius of outer circle is 1 meter, inner circle is 0.75 meter. So by 1, which means it is 20 radians. Okay, so the change in angle when this object moves 20 meter is 20 radians. Okay, the alpha is given in the problem, theta is available. And what about the initial condition? Initially the object is at rest, which means that in the problem it is given that omega naught equal to 0, v naught equal to 0, or sorry, u, it's not, okay, u equal to 0. These are the two conditions that is given in the problem. Initial angular velocity and initial linear velocity is 0 for the system. So with this I can use the expression we have theta is equal to omega naught t plus half alpha t square. We are using this, we have the value of theta, we have the value of omega naught, we have the value of alpha, the only unknown is t, and that is what is asked in the question. So you can solve this. So 20 is equal to, this term becomes 0 because omega naught is 0. So 0 plus half into alpha is given, which is 2 times t square. So basically 2 cancels out. So what I get, t square equal to 20, which implies t equal to root 20. Okay, root 20, we are going to get it as 4.472 seconds. That is the time required if this pulley is rotating at an acceleration of 2 radian per second square for object A to move by 20 meter. Okay, so that's the first part, we got the time. Now the second part of the question is we need to calculate the velocity of A and B at that particular instant. Okay, so what will be the velocity of A? So forget the velocity of A, we need to have the angular velocity of this, right? What will be the angular velocity of this particular pulley at this particular instant? So we have omega naught, we want to calculate the angular velocity of this particular pulley. Once we have omega, we can calculate the velocity. Velocity is equal to r omega. So velocity of A will be Ra times omega, velocity of B will be Rb times omega. So how to calculate omega? We have all the information. So we can use the expression omega equal to omega naught t plus, that is basically V equal to U plus AT. V equal to U plus AT, that is alpha t. So what will be omega? Omega naught is 0, so this term becomes 0. Alpha is given in the problem 2, and time we got it as 4.472. So I'm going to get the angular velocity as 8.94 radian per second. So I have the value of angular velocity. Now what I want is the linear velocity of A and B. So the angular velocity will be same for all the different points on this, right? So if I consider this point or if I consider this point, they are going to have same angular velocity. What about the relation between linear velocity? So from this I can write VA is equal to RA times omega, VB equal to RB times omega. So RA is given in the problem. RA is 1 meter. So 1 into 8.94. What about this? RB is 0.75. So 0.75 times 8.94. Okay. So we have the magnitude, but what about the direction? Okay. If the velocity of A is downward, velocity of B will be upward. So when you are reporting the final answer, you should be very careful if you are putting, so you should define some sign convention before reporting the final answer. So what I'm doing is I'm reporting it like I'm considering this as my positive direction of motion. Okay, so the movement of B, because we assumed clockwise rotation, okay, assuming the rotation to be clockwise, because nothing is said in the problem, we need to assume it. So I'm assuming clockwise rotation and I'm considering this as positive, which means that VA will be, it is moving down, which means VA is minus 8.94 meter per second. It's not radian, meter, because linear velocity. And what about VB? VB is 0.75 times 8.94. And what is that value? When I calculate it, I'm going to get the value as 6.75 meter per second, and it is positive according to the sign convention I decided. Okay, as a sign convention is not said in the problem, I can decide any sign convention. I decided this as sign convention and I got the values like this. So this is how we solve the problems involving linear and rotational motion. So this is basically a curvilinear system. Okay, something is rotating and something else is moving linearly, a combination, and this is how we solve it. And the step pulley is a very common question you can expect for the examination. Okay, so you need to practice more problems. regarding this. So keep practicing, and if you are having any doubts regarding this thing, feel free to contact. Okay, thank you.